In this next video, I'm going to show how to add a node to an existing Kubernetes all-in-one installation like I've shown in my previous video. So the first thing I'm going to do is I'm going to create another node. Here's my master here that we created in the previous video. I'm going to go and just create another one after my session has expired. And we'll just call this one node 1 in case we want to add other nodes in the future. And we'll start that up. Assign that a floating IP. Okay, so here's our node cloud instance. I'm going to get some packages installing on this, so we're not waiting on this. But basically, the node, we didn't all-in-one before, so it included the node packages before. But the packages that we need for the node are kubernetes-node and flannel. And we're going to have to install and configure flannel on the master as well. Flannel is the VXLAN tunneling that allows pods on different nodes to appear to be on a flat network together. And I'll go into that later on. But we'll start those installing so it doesn't delay later. So back over to the master. Right now the master is configured, everything's listening on localhost. When you add another node, it can't access the API server, it can't access etcd. So we need to change some configuration on the master in order to let external nodes talk to the API server and etcd. We normally wouldn't need to let the other node read etcd because the API server is the one who talks to etcd. But in this case, the flannel configuration is an etcd, so it needs to be listening on something other than localhost as well. So we're going to start by going into the Kubernetes configuration files, and we need to go to the API server. And there's an attribute called kube API address, and right now it's listening on localhost. We need to change this to the all addresses IP, which is just all zeros. Then that is actually the only change that we need to make for the Kubernetes configuration. For the etcd configuration, we need to go to the etcd configuration file. And there are two things we need to change here. The listen client URLs. Right now it's only listening on localhost. We need to also change that to the all addresses. And then on the advertised client URLs, we need to change this. You can put the IP address of this node in here, or you can do it by name. I'm going to show you how to do it by name just because it makes it nicer to look at. We're going to call this master. Now, depending on how you're doing this, you might not have DNS resolution for the names of these systems. So I'm just going to go into etc hosts, and we're going to add these things manually. Depending on your DNS setup, you may not need to do this, but this is a step that will make this demonstration work on almost any setup. So I'm going to go get the IP addresses. This master is 18, node 1 is 19, 18 and 19. So we're going to go 18 is master and 19 is node 1. We're going to have to do the same thing on the node. That way the master and node can resolve one another, which is important. So now that we've changed these two files, we need to restart the API server and etcd. And we'll just make sure that those came back up. All right. It appears they did. So the next thing we can do, we need to install flannel on the master as well. So let's go ahead and do that. DNF install flannel. All right. And Flannel is fairly simple in its design. There's only one configuration file. It's under etc sysconfig flannel. VI. Sysconfig flannel. There we go. And so on the master, you can say flannel etcd is localhost because etcd is actually running on this node on this system. On the node that we just spun up, this will have to be master. But we don't actually have to change anything in here. So we can just, the thing that we do need to do is this flannel.conf file that I've created. Let me show it to you. It's basically just a JSON formatted file. And what this is it creates a, this is the flat network that all the pods are going to be talking on. And the way Flannel works is Flannel starts up on each node, and it goes out and retrieves this configuration from etcd, and then it picks a /24 out of this /12 to use as the subnet for the pods on that node. And then it registers with etcd saying, I've got this subnet. And whenever you have pod-to-pod communication that is the pods are on different nodes, Flannel uses etcd to figure out the routing. So we are going to put that configuration into etcd, and this is the command for that. It's kind of long, but basically we're putting the JSON file into this key in etcd. So if we hit that, and then we can do an etcd control get on that just to make sure that it went in, and it did. So from there, now we can start Flannel on the master. I said the master, it's the all-in-one. It's also a node, right? Normally you wouldn't run Flannel on the master because it doesn't have any pods, but in this case, it's an all-in-one. It does have pods. So we're going to do start Flannel D. Okay. Let's take a look at the status here. Make sure that not getting, it looks like everything went right. And if we do an IPA, we can see this new Flannel bridge here, and we can see that it has picked the .69/24 subnet for the pods that are going to be running on this node. So that's good. So now let's run over to the node real quickly. So over here, we're going to have to configure Kubernetes to contact the remote API server. The API server is not on localhost anymore, so we're going to have to change some configuration files to let the node know where the master is. So under config, we need to come in here and say the kube master is at master. And that reminds me, we need to go and create this etc host file, right? So that they can resolve one another. And we will just copy and paste this here, put it right there, right? So if we ping master now, we can get it and make sure that that's right. So we get APA and right here. So that's good. All right. So the next thing we need to do on the node is edit the kubelet file. We're going to go in here. The kubelet address, for some commands, the master needs to contact the kubelet, which typically it's the other way around. Typically the kubelet is reporting status to the API server, but for things like kube control exec and kube control logs, it needs to send commands down to the node. So we need to be listening on all addresses here. And on the host name, we're going to use, since we're using node 1 in our etc host file, we're going to use node 1 here. And then the API server is at master. All right. Let me think that I've done everything. Okay, so now I think that we can just enable all of the node level services. Oh yeah, we'll change one more thing. We need to go into sysconfig flannel, and we need to tell it the etcd is running on the master. All right. So now we are going to enable and start flannel, Docker, the kubelet, and the kube proxy. All right. And we'll check on that. All green. Okay. Let's do a general control follow. And we're not getting recurring error messages from any of the daemons, so that's good. If we do an IPA, we see that our flannel is here, and it claimed the .6/24. So that's good for the pods on this node. Now that the kubelet is running on the node, we should be able to run a kube control get nodes. And you can see that node 1 is now in the nodes list and shows up as ready. So pods can actually be scheduled to it. So, I mean, we can do that now. Let's start a pod. We can do kube control, create, Fedora. Oh, already exists. So kube control, get pods. We can see that this is already running. If we do a describe on the pods, you can get which node they're running on somewhere. I'm not seeing it right now. But if we go into, that's what this is for, right? Topology, you can see we've got our node. Let's see if we can refresh this. There we go. So now we have our two nodes here. There's node 1, nothing scheduled on it, and our old Fedora demo pod is running on the all-in-one master. So because we're using the spread scheduler, if we start another pod, it should start on node 1. So we can see if that works just by editing this pod a little bit so that the name isn't duplicated. We'll do demo 2, and we'll do a create. And we'll see what that looks like here. So we can see that the Fedora pod got scheduled on our new node. And if we do a watch on it, if we do it in a hurry before the image pulls down, there we go. We can see that demo 2 was in container creating, which means it's pulling down the image from the Docker hub onto node 1. And as soon as that completes, the pod will start running on node 1, our new node. And now it's running. If we go out and we do a kube control exec, now remember that this is not like Docker exec. It would look for it locally on this node. We can do kube control exec, and it's actually running on a different machine entirely, but we can still get, kind of a TTY level access on even a container running on a remote node. So we're going to do demo 2, bin, bash, and now we're in the demo 2 pod. So we just added a node to our all-in-one Kubernetes cluster.